Do you love math? If you do love math, I suggest to go to www.mrmathinc.net or YouTube Mr. Ing today. Very easy and compatible to work with.
Hey guys, let's go over this 3.0, that should say 3, Polynomial Function Introduction Pretest Post-Test. So down here, the pretest, complete this pretest. This is not for a grade, but check your answers. So go ahead and fill this part out. I think I told you to do that later, but let me just go over these questions here. Question number 1, which function can be used to solve x to the third minus x equals 2x squared minus 2 by graphing? Okay, when it says the word solving, you are basically trying to find where it crosses the x-axis. And when you find where it crosses, you're making basically your x value a 0, and we find a y coordinate. To do that, I'm going to move everything over to one side of the equation, and you're going to have x to the third minus 2x squared minus x minus 2. Okay, is there anything that we could do here? Well, I notice that there is a x squared that we can factor out here from right here. X squared, so that leaves us x minus 2, and then I can factor out a negative 1. I'm sorry. No, don't factor out negative 1. Well, that actually solves the answer right there. If I move everything over, that should be a plus 2. That would leave us option A as our answer. Okay, question number 2. All right, let's go over question number 2. The graph of f of x is shown. Complete the statement. How many real zeros are there? The real zeros are going to be anything that crosses the x-axis. So you have 1, 2, 3, and 4. Now, it's not just the crosses. It shoots through, or shoots like a tree through the land of x, from underneath the ground to above the ground. So in this case, we have 4 real solutions. Question number 3, use a graphing calculator. You can, but I'm going to show you guys how to do this without a graphing calculator. So if I subtract 4, I'm going to move everything to one side. That gives me 0. I add x. X to the third minus 9x equals 0. Factor out an x. If I factor this again, remember that is x squared plus 0x minus 9. So when you factor it, your b value is 0, and you get 3 and negative 3. I'll show you guys the proper way. So you really need to write x minus x minus. So this will become x minus 3 and x plus 3, and then when you set each of these equal to 0, you'll have x equals 0. This becomes positive 3, and this one becomes negative 3. Okay, so those are your 3 solutions here. So that would be B, A, and D. Skipped a couple questions here. Find the solutions. You're going to do the same thing. I'm going to set this equal to 0 by subtracting. None of those are like terms. And you'll notice that you can pull out a greatest common factor. Let's pull out an x. And what's nice about that is it turns it into, inside the parentheses, there's quadratic. The two numbers that multiply are going to be 9, 1, negative 9. So you have x. Now, you might be wondering, why do I write x minus? That's just the form that it needs to go into Actually, let's not teach you guys that right now. We're just teaching you a factor, which I've shown you guys. And then you set each of these equal to 0. And get x equals 9. And x equals, that should be a plus 1. X equals -1. So -1, 0, and 9. Let's go on. All right, this next question asks us to put these things in order. And you have 4 terms here, so let's count them. 1, pencil's not writing. 1, 2, 3, 4. And you're going to try doing something called factoring by grouping. So I'm going to call this my first step. I'm going to pull out an x squared as my greatest common factor. Then I have x plus 4 that's left. Now, the x plus 4 is what I'm going to try to get over here on the other side. So in order to do that, I'm going to have to probably pull out a -4. So that it reads x plus 4. Remember, if you distribute the -4, you'll get -4x minus 16. So again, those things are the same. Okay, now which one has the step I just did? That would be step F. Okay, let's try the next step. Now, in pink there, I have both an x plus 4. So we're actually going to factor out something called a greatest common factor of x plus 4. And what's left here is just x squared minus 4. So x plus 4, x squared minus 4. And that would be this choice. Okay, and the next step I'm going to do is I'm going to factor this one out. Remember, it has a 0x, so this is called a difference of squares. Name is not important, it's just as long as you know how to factor it. A times c and your b value, so that would be 2 and -2. And the x plus 4 is the same. Okay, let's find one that looks like that. X plus 4, x minus 2 right here. Okay, then our last step in what we have here is to solve, because it's always set equal to 0. And so step number 4 is just setting each of these equal to 0. And when you solve, you get -4 here, -2 in the middle, and then 2 on the right. And that is choice 2, -2, -4. That would be this one right here. So that's how I would put those in order. Okay, question number 7. This one is called factoring quadratic like. The Xbox method over here, trinomial, works when you have a trinomial. So you have 1, 2, 3 terms. And then what's important is you also have half of 4 is 2. Now that works like we did over here. Half of 2 is 1. So this method will actually work if I just use Xbox factoring. So this is called quadratic like. Quadratic like. Now, they also call this factoring a Quartic trinomial. You can also call this a substitution method, but it's essentially the same. So a times c would be -2, and my b value is -1. My two values are -2 and 1. So I'm going to put the -2 and +1. Now pay attention, this is new to you. Instead of writing x there, you're going to write x squared. And the reason why this works, let's go ahead and just, this is why the x box method or area model works. So the first term always goes in the top left. The last term always, c value always goes in the bottom right. Now this has split the middle term. -2x squared plus 1x squared equals -1x squared. So if you put this here and here, greatest common factor is x squared, -2 x squared, and this one looks to be a positive 1. And remember, you can multiply on the white to go inside. So outside to inside, you can multiply. Now, the solutions are basically solving. Solving means where x is equal to something. So I'm going to set each of these equal to 0. And let's go ahead and work on this left side here. I'm going to add 2. I'm going to take the square root. Remember, when you take the square root, you have plus or minus. So this is going to read x equals plus or minus radical 2, which is choice C. Now, the plus or minus basically means, I'm going to circle that as my answer, but basically that means you have something that looks like this. This is one answer, and this is the second answer. Okay, let's try the right side. This one will be a little bit new. I'm going to subtract 1, so I'm going opposite of PEMDAS. And then I'm going to take the square root, like we did over there. You're left with just x plus or minus. Okay, here's a fact that is new. I equals the square root of negative 1. I equals the square root of negative 1. This I represents an imaginary number. It's not on the real number system. It's on a different number system, the complex. And so instead of writing square root of negative 1, I'm going to do a substitution. We're going to call this I. And that's my answer. That would be choice E. That would be the same thing. X equals I and x equals negative I would be your two solutions. Okay. Number 8. Marco is making sails for his model sailboats, and dimensions are shown. They have the same area. Okay. If they have the same area, that means the blue is equal, or everything over there is equal to the pink. Does that make sense? The pink is equal to the blue. So I have x times x plus 4, because we're talking about area, which means to, we talked up here, is actually multiplying. And we're going to multiply over here. So 2x plus 3 and x minus 2. I'm just going to expand this. You can use FOIL or the box method. Two x squared negative 4x, 3x minus 6. So that means the pink side, should write that in pink. 2x squared minus x minus 6. Distribute x squared plus 4x. And let's go ahead and move everything over. Minus 4x. 0, 0. There comes x squared minus 5x minus 6. And again, solve quadratics here. You can use your area model. Not your area model. Yes, your area model. I'm just going to use the x here. B value is negative 5. My two numbers are negative 6 and 1. So 0 equals x minus 6, x plus 1. Set those equal to 0. And you'll get x equals 6 and negative 1 is our answer. All right, number 13, if x equals 1 is a factor, find the remaining factors. Okay, so this means that in the factor theorem, if it is a factor, then the remainder is equal to 0. If the remainder is equal to 0, that means the rest of it is the true polynomial. So x minus 1 equals 0, and you'll get x equals 1. And what I do with this 1 here is I'm going to go ahead and just use synthetic division, and then I'm going to write my coefficients: 1, negative 8, 19, and negative 12. bring this down, multiply, 1 times 1 is 1. You're going to add, multiply, add, multiply. Okay, I already knew that the 0 was going to happen because this is a remainder. And so what it's done is it's decreased its powers. So 12 is a constant, you just add an x, and this one's x squared. So if you really want to see it, it'd be something like that. Super clean, looks like this. And then we just need the factors. So if you bring this one down, this is really x minus 1. And if I factor this one more time, this would become 3 and 4. So therefore you would have x minus 3, x minus 4, and we already knew what x minus 1 was. So question 13 has answers B and D. All right, for this last question, it tells us to match the descriptions below, but basically what I'm going to do is going to factor and try to solve it. Now, the first thing I notice is this last term has an x squared. So let's see if I can pull out an x squared from all of this. And I can. So what I'm doing is I'm subtracting the exponent by 2. So 5 minus 2 is 3, 4 minus 2 is 2, and 3 minus 2 is 1. And then this one is just a 1 here. Okay, from inside here now, I'm going to use the rational roots theorem. So this is the p, and this is the q. So p divided by q is 1 over 1, positive, negative. So I'm going to test 1 and negative 1. Let's try negative 1. And again, I'm trying from inside the parentheses, so I have 1, negative 3, 3, negative 1. See if this works. Bring it down. 1, multiply, add, multiply, add, multiply, add. And that number is not a 0, so that one didn't work. Let's go ahead and try positive 1. 1, negative 3, 3, negative 1. Bring it down, multiply, add, multiply 1 times negative 2 is negative 2, add, multiply, add, and we get 0. Okay, so this tells me, so I have x squared. Pay attention, this is going to become, this is x equals 1, right? So if you subtract 1, you get a binomial of x minus 1. Okay, what's left here? Remember, this is the remainder. So the 1 is a constant. Add an x, and this one's x squared. And then you have a quadratic here, and then I can just factor that again. So let's go ahead and factor that. There in blue, a times c is 1, b value is negative 2. My two numbers are negative 1 and negative 1. Negative 1 times negative 1 equals positive 1, and negative 1 plus negative 1 equals negative 2. So I'm going to write x minus 1, x minus 1. And so our final answer, or the best answer we can have here, is x squared, x minus 1 to the third power. Okay, then it's telling us that, how would you describe negative 1 in our answer here? I would say that you're tempted to think it is a 0 or a multiplicity of 3. And the answer is no. Because remember, x minus 1, you come back up here and you realize that the 0 is at x equals 1. X equals 1. So we can say that the 1 here, we can say that, well, the negative 1 is not a 0. 0. Now, if you set this equal to 0, you get x equals 0. And remember, the multiplicity word is this right there. So this has a multiplicity of 2. 0 of multiplicity 2. And then this one has a multiplicity of 3. So that's x equals 1. Again, how do I get that? I'm not going to write it out 3 times. You can, but I'm not going to solve each one of those because it's redundant. It's the same thing. Add 1, and you get x equals 1, which is what we want here, right? So this one has a 0 of multiplicity 3. And that's it. See you guys later. Bye.
Two plus 2 is 4, minus 1, that's 3 quick maths. Everyday man's in the class, doing problems. See the problem board, that problem is easy, thanks to Mr. Ing.